You know, in part because you studied this in middle school, there are three ways for heat to be transferred: conduction, convection, and radiation. In this video, we'll discuss conduction. Before I do that, heat is represented by a capital Q, isn't it? So if I say 2,000 joules, by the way, joules is the unit of measure. If I say 2,000 joules of heat, we'll say Q equals 2,000 J. All right, now conduction is by contact. For heat to transfer between two objects via conduction, they must be in contact. Now here, you would say these two hands are in contact, right? Yes, so conduction can occur, and of course it always goes from warm to cool, doesn't it? Or hot to cold. Sure, it's always in that direction. So we see the cube going here from the warm hand to the cool hand, from warm to cool, and it's going by contact, so this is definitely conduction. We see it again here, contact is required. If there's no contact, there's no conduction. Here we have contact, yes, conduction, yes. Here we have a warm to cool hand, but they're not in contact, are they? So that little arrow there with the Q going across, there's an X there. There is no transfer of heat by conduction. Contact, no. Conduction, no. Here's another example. Let's look at, we've got the foot in both situations is 98.6 degrees, which you know that's the temperature of our body. Here it's in cold water at 50. Here it's in hot water. Now the first question, is there contact here? Between water and foot? Sure. The foot's wet, isn't it? Contact, yes. So what kind of a transfer of heat is it going to be by contact? It's going to be conduction, isn't it? Okay. Now let's see. Let's move that out of the way. From here, it's the warmer foot. Doesn't it go from the warmer foot to the colder water? Yes, here we should say from foot to water. What's warmer here? The water, isn't it? So here isn't it going to be from water to foot? Yes, it will be. Last thing, we're going from foot to water, so we need to use that, don't we? From the foot to the water, Q being heat, of course. And here, from water to foot, we'll do that, won't we? Okay? Water to foot. And there you go. There is contact here between water and the foot, so there's conduction. Now here we have air here, and here is water here. And would you agree, is the air in contact with the water? Sure it is, right there, along this line here. So is what kind of transfer of heat are we going to have? Sure. It's going to be conduction, isn't it? Is there contact? Yes. Does heat conduct? Yes. So it's going to be, right here's a point where the air and the water are in contact. So we're going to have conduction, aren't we? Now which one's warmer? In this situation, the air is warmer, so it's going to be, is it going to be like this? From the air to the water via conduction? Sure. There's contact from warm to cool. How about here? Have I just switched these two? Isn't the water warmer now? I think it's going to do this, isn't it? They are in contact. It is conduction. Warm to cool. Water to air this time. Let's say we did this kind of thing. Let's say we took an 80-degree block of steel, we place it in a 20-degree beaker of water. Okay? So what's going to happen here? First of all, do we have contact? Of course we do. Steel to water. Yes. So what kind of heat transfer with contact? Yep. Conduction. From where to where? Warm to cool. Metal to water, right? So let's see, it goes from the metal to the water. So I think we have to use that one, don't we? There we go. Warm to cool. Now the last thing I want to talk about here is when the heat stops transferring. Now we start here at 80. We know heat's going to come out of here and go to the water. So isn't this guy going to cool? Isn't he going to warm? Well, could this guy warm the water all the way up to 80 and stay at 80? No, he's going to cool some, isn't he? That's out. Well, heat's going to go from here to here. The outside's going to get warmer, isn't it? It's not going to stay at 20. Now, this makes some sense. This guy lost some heat. His temperature went down. This guy gained some. But won't they keep flowing here? Won't the heat keep flowing? Because there's still a heat difference? This is the kind of thing that could happen, isn't it? Right. The heat did go from the steel to the water, warming the water, but the heat kept transferring until both of them were equal. These two were equal temperature, didn't it? Sorry. And so that's when it stops. Only when the temperatures are equal. Bye.